Hello.
Good evening, sir.
Yeah, good evening. Did you have any tests last week?
No, we did not have any tests. The tests start from tomorrow again. So I was just doing the NTA papers instead.
Uh, so NTA papers don't solve in time, okay?
Yeah, like you said, I go
Yeah,
through the questions which I know that I can do, and only some of them which I think maybe I won't be able to, I try them.
yeah, because there are so many papers that you should cover more and don't worry about times and all. Just do what you feel like you should try out and find the doubts and find the problems. And
Yeah.
don't spend time too much on like don't do revision of the subject by looking at the chapter. Do revision through NTA questions. Okay.
Yeah, I started doing the chapter wise papers as well. So I was like halfway done with it.
Hmm. Okay. So now the exams are closed, right?
Yeah.
April end, there is no one.
Boards are starting from 7th May, so there's no exam before that.
And JEE mains is in May or April also, no?
JEE mains is in June now.
Oh, huh, it got delayed, right?
Yeah.
JEE mains is in June and okay, boards are from 7th May.
Yeah, only KVPY and BITSAT is coming up right now in May.
Hmm.
Other than that, everything is in June.
When is KVPY?
KVPY is on 22nd May.
And boards, your five papers will be which days?
We have 7th May chemistry,
Hmm.
10th May English.
Hmm.
Then we have one exam on 13th May.
Hmm.
Oh no, actually 10th and then 20th May, then 7th June and 13th June.
It will go until June.
Yeah, till 13th June.
Okay, fine. Okay, let's do some PNC questions and sort of revise this for at least the mains level. So this is the first one. From a group of 10 profs, A1 to A10, how many ways can a committee of 5 members be formed so that at least one of the profs, A1 and Prof A2, will be included?
So either A1 or A2 must be there, right?
At least one. Both could also be.
Okay. So we can do it case wise, right?
Hmm.
So case one would be that A1 is there.
Hmm.
In that, uh, it will be 9C4.
Hmm. A1 is
And
there.
similarly for A2 also it will be 9C4.
Hmm.
And when both are there, it will be 8C3.
So,
And all this will be added because any one of them can happen.
so be careful here. Uh, think about it a little more. All this will not be added. You have to be careful.
The first two will be added and the last one will be subtracted
Hmm. Why?
because
This is the answer. But why? This is called principle of inclusion and exclusion. Principle of inclusion and exclusion. So, what it says is that if you have to find something this or this, right? At least one of the
Yeah.
profs, this and this must be there. So either prof this must be there or prof that must be there, right? So if you have to find
Yeah.
number of elements in A union B, you can find number of elements in A plus number of elements in B minus number of elements when both are there. Because when you count A1 is there, that already includes the case when A2 was also there, but A1 is there, right?
Yeah.
So if A1 was, you're counting number of ways in which A1 was there, that may have A2 also, right? So this intersection portion, let's say X, is already included once. Here also, this intersection place portion is included once more, right?
Yeah.
So then if you just add this when both are there, then you're counting this region 3 times, right?
Yeah.
But if you subtract it, then from 2 times you have already counted this region and you minus 1, right? So then you're counting this portion, and this portion exactly once, right?
Yeah.
So be careful, like you don't have to overcount. So be careful whether you're overcounting something, right?
Yeah. Could we do this another way?
What?
Like the total would be 10C5, and could we just subtract the case when both of them would be there?
Both of them will be there is not a bad case. It is allowed. Why will you subtract it, right? Both of them would
Sorry.
be there is allowed. It's just that you're not allowed to count it multiple times, right?
Yeah. Sorry, I meant like
Neither
both
of
of
them
them
are
are
there.
not there. Yeah.
Now you can take total number of cases 10C5 minus none of them are there, right? That is an easier way to do it. So
Yeah.
none of them are there would be how many ways?
8C5.
Hmm. So that is also a direct way to do it. That is complementary counting. So that is an indirect way to count it. But even if you wanted, you could do direct counting also. But direct counting, don't make the mistake of counting the same place 3 times, right?
Yeah.
Okay. Let S is equal to this set. Find the number of unordered pairs. Unordered pairs. A comma B of subsets of S. Subsets of S such that A and B are disjoint where A or B both may be empty. Okay.
Yeah. Is it 3 power n plus 1?
How are you thinking about that?
Or disjoint sets meaning A intersection B should be phi.
Mm-hmm.
So every element which is part of the set S could be either part of A or B or neither.
Mm-hmm.
So if we take that, the total number of
Mm.
ordered pairs will come up to be 3 to the power n because there are n elements,
Mm-hmm.
and plus 1 because they can be empty as well.
3 to the power n plus 1 like this
Plus 1 down, not in the power.
can be empty as well. Uh, why are you doing but plus 1? Like when both are empty, you're saying.
Yeah,
Uh, but this is counting ordered pairs. You should divide by 2 because it's unordered, right? Unordered, no? Like two of two of the unordered pairs, two of the ordered pairs count as one unordered pair, right?
yeah, okay, yeah,
So AB and BA will be counted separately in the way we are counting right now.
yeah,
So they actually count as just one AB here, right? So
yeah,
basically the idea is that each element can have an option. One can either be in A or it in B or neither, right?
yeah,
So, okay, so three choices, the 3 power n, but that includes the case when all of them are in neither, right? 3 power n, it should be 3 power n minus 1 by 2. And this includes the case when 5, 5. But you have to count plus 1. I think you have to get, you'll get this answer because you have to count the one case when it is 5, 5, right?
yeah,
Normally you would say 3 power n minus 1 by 2 for unordered. Not sure whether this is plus 1 by 2. You can take small numbers. The best way to understand this really well is take just small numbers, right? S is 1, 2, 3, and then just see whether this formula gives you the correct answer. N is 3 here, right?
yeah,
They're saying that 3 power 3, which is 27 plus 1, 28 by 2, 14 ways are there.
yeah,
Actually, even take smaller ways. The S is 1, 2, let's say. Only 2. And then 2, 3 power 2, 9 plus 1,
5,
5 ways, right? Now
yeah,
we have 5 unordered pairs of subsets here where they're disjoint. So phi and S, right? And 1 and 2, right?
yeah,
And 1 and 5 and 2 and 5. Okay, okay. And then 5 and 5, right?
yeah,
So the formula is fitting. Like I was unsure about the plus 1 part, right? But it makes sense, right? 5 options are coming,
yeah,
right?
yeah,
Okay. Uh, so if you are unsure, like you have the almost the you have the correct idea, but if you're unsure whether it is 3 power n minus 1 or plus 1, then you should check for small values, right? If the set
okay,
was really small, you can actually list down whatever unordered pairs are there, right? And then
yeah,
see which formula works, right?
yeah,
And anyway, if the options are available, then it will be easier to decide that, right? These are all objective questions. Options will be available in the exam. So then you can just decide that, like by even listing out the things, right?
yeah.
Okay. Uh, Question 3 is this. In how many ways can we choose a black square and a white square from a chessboard? And a white square from a chessboard, so that they are neither in the same row nor in the same column. Neither in the same row nor in the same column. Now you need to know that the chessboard has 8 cross 8,
Yeah.
8 cross 8, 8 rows, 8 columns, 32 white, 32 black squares.
If we like take one of the colors, so we could choose the black square in 32 ways.
Hmm. Like,
And
first, don't put any restriction. How many ways can you choose a black square and a white square without any restrictions, right?
yeah, 32C1 for
Hmm.
black and 32C1 for white.
So that is the total number of ways. And now you have to exclude the cases when they are in the same row or they are in the same column. How many ways will both the squares be in the same row? Let's say.
Like 8 into 8C2.
Uh, no, there is a difference. It's not like all the squares are identical. No, you cannot do directly 8C2. So there are 4 white and 4 black. That might end up having 2 whites, right?
Yeah,
You have to choose 1 white, 1 black, right?
yeah,
So in the same row, you will do 4C1 into 4C1, right?
yeah,
And that could happen in any of those 8 rows. So 8 into that.
yeah,
And similarly, in the same column also, you will do same thing.
yeah. So 2 into the above thing for the total.
Huh. 2 into that thing. 2 into 8 into 4C1 into 4C1. That is like 16 into 16, right?
Yeah,
So it is 256, and you have to subtract 1296 minus 256. I think 32 square is what? No, it would be something else. 1024.
1024,
1024 minus 256. Right?
768.
Yeah. So You have to be a little careful, but not very difficult. Uh, then just hold on a minute.
Yep.
Construct a rational number a by b in the lowest form. No common factors and all. A and b are integers. 0 is less than a by b is less than 1. B is greater than 1. And you have to find how many of these have AB is equal to 15. Oh wait, I made a mistake. AB is not 15, it is 15 factorial. If it was just 15, it's very easy, right?
Yeah. You can
Just
just,
count it, just list it out.
yeah.
So it is not 15, it is 15 factorial.
So A and B would be prime, right?
They have to be relatively prime to each other. They don't have to be prime numbers, right?
Yeah.
Because if they don't are not relatively prime, then you cannot get it in lowest form. You'll cancel off stuff then.
Yeah.
So whenever you have to find something, you have to find basically two numbers whose product is equal to this, right?
Yeah.
And they are relatively prime to each other. So how many relatively prime factors can you find for 15 factorial, right?
Okay.
15 factorial, if you think about, or just 15 is, okay, that is not helpful. So 15 factorial is 15 into 14 into 13 into like this 12, 11, 10, 9, 8, 7, 6, 5, 2. So why am I writing this? Because that will give you prime numbers and all, right? How many prime numbers?
Yeah.
Or prime factor expansion basically. 2 power, 1 here, 2 here, 3, 4, 7, 8, 4. So 10, and then 11, right?
Yeah.
2 power 11, 3, 1, 1, 2, and 2,
6.
4, and then 5, and then 6, right?
Yeah.
So 5 power 3, and 7 power 2, 11 power 1, and 13 power 1, right?
Yeah.
This is your 15 factorial. Now, out of this, you have to express it as a product of prime divisors, right?
Yeah.
Okay. So How will you do that? Uh, so anytime you take a 2, all the 2's must go in 1, right? Like,
Yeah.
you understand what I'm saying?
Yeah. Otherwise, it will get divided even further.
So if I have to select A, right,
Yeah.
then I either take all the 2's or none of the 2's, right?
Yeah.
Correct.
Yeah.
And there are two ways to do it. Basically, take 2 power 0 or 2 power 11, right?
Yeah.
Similarly, all the 3's or none of the 3's, right?
Yeah.
And I do this for each prime factor, right?
Yeah.
But if I do this for everyone, what will happen is I will have be left with all or none, right? The entire number, like I can do two ways to do for two selecting 2's, two ways for this, two ways for this, right?
Yeah.
Two ways for this, two ways for this. And then maybe two ways for this. So, but then what happens is one possible number out of that is everything, and one possible number is nothing, right?
Yeah.
So I have to select B also. So what I have to do is basically,
And A will have to be less than B because it's from 0 to 1.
hmm, hello.
Yeah. I think you got disconnected.
Yeah, yeah. Okay. So the best way to do that, I think, is not to worry about such a big thing. Let's do the same thing for 3 factorial, right? 3 into 2 into 1. So I have 2 power 1 and 3 power 1, right? Like I want to get a pattern. Like, can I split it as A by B according to the same conditions, right?
Yeah.
So here, okay. So here, so we can actually list out the things, right? It will be 1 by 2, 1 by 3, 2 by 3, right?
Yeah.
And is there anything else? 1 by 6, right?
Yeah.
Correct.
Yeah.
This is the ways in which I can make this, no?
Yeah.
Okay. So basically I'm getting 4 ways, right?
Yeah.
Like if I had 4 factorial would have been 4 into 3 into 2. It would have been 2 power 3 and 3 power 1, right?
Yeah.
Then I'm getting 1 by 3, 1 by 8,
1 by 4, 1 by 2.
1 by 4, 1 by 2 won't work because product is not equal to that, right? You either have to take all or you have to take none, right? You understand?
Yeah.
3 by 8 will work. You understand? You have to make product this, no?
Yeah.
1 by 4, 1 by 2 won't work, right?
Yeah.
And 1 by 24 will also work, right?
Yeah.
So again, 4 ways, right?
Yeah.
So the number of primes is 2. two different primes, you're getting 4 ways, right? In both cases, right?
Yeah.
Let's take some 6 factorial. So you'll get now no more than 2 primes. 4 into 3 into 2. So you have 2 power 2, 1 and 1. So 4, 3 power 2 and 5 power 1, right?
Yeah.
So you will form basically numbers like 1 by the whole thing, 6 factorial, right?
Yeah.
6 factorial is 720, right? Yeah. And then you will form what? 3 square by this into this, right?
Yeah.
Or you can form 5 power 1 by 2 power 4 into 3 square, right?
Yeah.
Form 2 power 4 by 3 square into 5 power 1, right?
Yeah.
And now you can take combinations of 2 as long as the top part is smaller than the bottom part, right?
Yeah.
So 2 power, okay. So this 2 by this doesn't work. These 2 by this also doesn't work, right?
Yeah.
And this and this by this also won't work. So that doesn't work. Is there any others? 3 square by this. Hmm. This a by b less than 1 restriction is sort of annoying, because if a by b less than 1 was not there, right, you would have what? You would have all of the other options also, 2 power 4, 5 power 1 by 3 square, right? And
Yeah.
2 power 4, 3 square by 5 power 1, and 3 square 5 power 1 by 2 power 4, right?
Yeah.
And finally, you could have the opposite, 3 square 5 power 1 2 power 4 by 1, right?
Yeah.
These are the all the possibilities, right, of making rational numbers.
Yeah.
So here you're getting 8 ways. 8 ways. So basically what we are seeing is the number of prime factors, that many ways are there, right? But 2 power 3, that many ways are there, right?
Yeah.
Without the restriction of a by b less than 1,
Yeah.
right?
Yeah.
And like we saw that in when there were 2 prime factors, you were getting 4 ways, right? And when there are
Yeah.
3 prime factors, your total number of rational numbers like this, you are getting 2 power 3 ways, right?
Yeah.
2 power 3 also makes sense here, because we are saying that for either numerator or denominator, you are either selecting or not selecting. So 2 options for each prime factor, right?
Yeah.
Correct. So
Yeah.
if you do the same thing when there are 6 prime factors, you should get total 2 power 6 options, right?
Yeah.
Either selecting or non-selecting the numerator, like 15 factorial, right?
Yeah.
But the problem is that that will not satisfy this stuff. Like many of them might be numerator is larger and stuff, right?
Yeah.
So right now, in the one case that we have seen, larger numerators are half and larger denominators are half, right?
Yeah.
So you'll have to test it a little more. Maybe take, say, 8 factorial. Now there are 4 different prime factors, right? Correct.
Yeah.
And you can write the prime factorization of this. There will be 2, there will be 3, there will be 5, there will be 7, right?
Yeah.
Like, hopefully you should get 2 power 4 ways to make rational numbers and 2 power 3 ways to make a by b less than 1, right?
Yeah.
Like if the pattern holds, 8 of them will be such that A by B will be less than 1, and 8 of them will be such that A by B is greater than 1, right?
Yeah.
Are you understanding what I'm saying?
Yeah.
So like you should check it once, because right now you're not certain. And hopefully then the answer for the question will become 2 power 6 by 2 or 2 power 5 or 32, right?
Yeah.
Now, why is this happening? I think it is because, like, again, here we are taking subsets, and if we don't take consider the order and all, then that many subsets are possible, 2 power 4. But we have to consider only one type of subset. So half of those, AB and BA, are not the same. Ultimately, it was symmetrical. No, all the powers of 2, 3 could go up or could go down, right?
Yeah, but shouldn't we subtract two cases from the total?
Which two
The,
cases?
like the case when both of the A and B are same.
Both of the A and B are same is not possible, because then you will cancel everything, right? How can both of A and B be same? Like, let's say here it is 2, 4, 8. How many powers are there? 2, 4, 6, 8. 1, 2, 3, 1, 4, and 3, 7, right? 2 power 7, right? And
Yeah.
3 power what? 1 and 6 also, so 2, right? And 5 power 1 and
Yeah.
7 power 1, right?
Yeah.
So you can make numbers like this, like 2 power 7 by everything else, right? You can make 3 power
Yeah.
2 by everything else, 5 power 1 by everything else, 7 power 1 by everything else, right? You can make 2 at
Yeah.
a time, right? And divided by everything else, right? Correct.
Yeah.
But some of
Yeah.
them will end up being in this group and some of them will end up being in this group, right? But the numbers will be equal, no?
Yeah.
And either this is greater than this, so this will not be in this group, but this will be in that group, right? But it's always going to be symmetrical, no? You understand what I'm
Yeah.
saying?
Yeah. 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 I understood.
So you have to make the product 8 factorial. So you'll have to split the factors some way. Half of them will be in such a way that A by B will be less than 1, and half of them will be in the way that A by B is greater than 1, right? You can't have any other cases, right?
Yeah. Yeah.
It makes sense. No, I think. Correct, no?
Yeah. Yeah.
So total number of ways is number of prime factors to power 2, and you divide it by half to select the cases where the fraction is less than 1, right?
Yeah.
Okay. Then this one, in how many ways can we distribute k identical balls to n different boxes so that each box contains at most one ball and no two consecutive boxes are empty. So slightly different question than the one that we discussed in the last class. Each box can have 0 or 1, right?
Yeah.
0 or 1 ball. And no two consecutive boxes are empty, right?
Yeah.
So like boxes can be two kinds, E or F, empty or full, right? You
Yeah.
can't have empty, empty, full, empty. This sequence won't work, right?
Yeah.
Right. So,
Yeah.
and also each box can have at most one ball, right? So
Yeah.
K balls will have to go to at least K boxes must be there, right?
Yeah.
Like we have K non-empty boxes, right?
Yeah.
Then only you can fill the K balls, right?
Yeah.
Correct.
Yeah.
So non-empty means full boxes. K full boxes are there, right? So if you put the full boxes like this, F, 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 and these are K of them, right? Correct.
Yeah.
So how many boxes are empty? N minus K. Since K are full and N are total, right? Correct, no?
Yeah. Yeah.
So N minus K boxes are empty, right?
Yeah.
And since empties cannot be together, the way to arrange it would be to put the empties in the spaces between the fulls, right?
Yeah.
Normally, whenever you say no two girls can be together or no two boys can be together, the way you do it is put the other ones in a sequence and put the girls in between them, right? You would have seen questions like that, no? Boys and girls have to be arranged in a row, but no two boys have to be together, right?
Yeah.
And what would you do? You'll line up the girls, and then the spaces between the girls, you'll have to put the boys, right?
Yeah.
So the same idea here. We have non-empty boxes, K of them, full boxes, and there are K plus 1 spaces now, right?
Yeah.
So what will you do? In the K plus 1 spaces, you have to distribute the empty boxes, right? And how many empty boxes are there? N minus K, right?
Yeah.
So the answer here will be K plus 1 C N minus K.
Yeah.
So are you understanding? It looks like the question, the type of question that we discussed in the last class, but it's actually not like that.
Yeah.
Not the typical stars and bars stuff, right?
Yeah.
Because there is a weird restriction that box can contain at most one ball, right? So box will either be empty or it will be full. And there are K balls, so there are K full boxes and N minus K empty boxes, right?
Yeah.
And you just have to arrange those types of boxes in ways so that the empty ones are not consecutive, right?
Yeah.
Are you understanding what is happening?
Yeah. I am.
Okay. Then mm, look at this one. 5 boys and 6 girls must sit around a round table How many arrangements are possible? Number of possible arrangements. If a boy, let's say Ram, must always be adjacent to, must always be adjacent to Sita and Geeta, two girls. Number of possible arrangements, one particular boy is always adjacent to two particular girls. This is a round table sort of a thing.
Is it 2 into 8 factorial?
Why?
Like the number of ways to arrange uh, people in a round table is n minus 1 factorial.
Hmm.
But because the condition is that the boy must sit adjacent to the two girls, we can just take them together.
Like this, right?
Yeah,
And then
yeah.
there are five girls and four boys. No, no, there are four girls and four
4
boys.
girls and 4 boys. So total 9 minus 1, so 8 factorial ways, and the girls can be interchanged.
Hmm. Yeah, so it is easy only once you know what has to be done in these types of things. Uh, then, okay, 1 second. Okay, question is, let A be the vector I plus J plus K and R be a variable vector such that R dot I, R dot J, R dot K are positive integers, are positive integers if R dot A is less than equal to 12. The number of possible values of R vector are what? See, R could be, you can take it as xi plus yj plus zk, right?
Yeah.
From the first condition, these conditions, you're getting that x, y, and z are integers, positive integers, right?
Yeah.
And from here, you're getting that x plus y plus z is less than or equal to 12, right?
Yeah.
So we just have to find number of solutions of this inequality, right?
Yeah.
X, Y, Z are positive integers, right?
Yeah.
So if you think about it, we know how to solve the equation x plus y plus z is equal to 12 when x, y, z are greater than or equal to 1, right?
Yeah.
Correct.
Yeah.
Here x, y, z have to be greater than or equal to 1 because they are positive integers. So how do we solve this? How many solutions will be there for this equation?
So we'll do that
Hmm.
stars and bars method.
Hmm. But there is a condition that it has to be one or more.
So we'll give them one before
Hmm.
itself.
So you have to actually solve x plus y plus z is 9, right?
Yeah.
The remaining after giving 1, 1, 1.
Yeah.
So that will be,
N plus
there are 9 things that have to be distributed to 3 boxes. So how many bars?
2 bars.
So 11 things now, right?
Yeah.
11 spots, 9 things and 9 stars, 2 bars. And you have to put
Yeah.
the 11C2 should be the answer, right?
Yeah.
Right.
Yeah.
So the number of solutions of this equation turns out to be 11C2 under these restrictions, right?
Yeah.
But it doesn't have to be 12, it could be 11 also, right?
Yeah.
Same restrictions, right?
Yeah.
So then it will be 8 here instead. And the
10
answer will be
C2.
10C2, right?
Yeah.
And you'll get 9C2 and so on. Till at the end, you'll get a situation where x plus y plus z is equal to 3 and x, y, z have to be greater than or equal to 1, right?
Yeah.
And here you will give 1, 1, 1, it will become 0. So x plus y plus z is equal to 0. And you'll get 2C2 or only one way, right?
Yeah.
So you'll go in a series from 11C2 to 2C2, right?
Yeah.
Right. Those are
Yeah.
the number of ways of doing this, correct?
Yeah.
Now, to get the answer, we have to find the sum of this, right?
Yeah.
2C2, I mean, ideally, you don't want to do the sum by actually calculating because if it was 48C2, then it would have been bad, right? Like
Yeah.
question could have been changed and numbers could have been big, right? So you want to find a way to find the sum, right?
Yeah.
2C2 plus 3C2 plus 4C2 and so on till 11C2, right?
Yeah.
So have you heard about the Pascal triangle?
Yeah.
So this is the Pascal triangle, right?
Yeah.
6, 4, 1, 5, 6, 1, 5,
10.
10, and 10, and 5, and 1, right?
1. Yeah.
So in the Pascal's triangle, actually, if you realize, the triangle is actually like this: 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3, right?
Yeah.
4C0, 4C1, 4C2, 4C3, 4C4, right?
Yeah.
These are the numbers actually, right?
Yeah.
So, uh, 5C0, 5C1. These are coefficients of your binomial expansion at each stage, right? Like
Yeah.
these are the coefficients that would appear in the expansion of x plus y power 4. And this is x plus y power 5. And this is x plus y power 3, x plus y power 2, right?
Yeah.
Correct. Then
Yeah.
there are a couple of nice things in the Pascal triangle. The first nice thing is obvious that this plus this is this, right? Right? That is how we
Yeah.
make the triangle in the first place, right?
Yeah.
So that gives you a nice identity. Now, what is the identity? See, 2C0 plus 2C1 is 3C1, right?
Yeah.
So any place you have, if you are in the same row, the top thing remains fixed, right?
Yeah.
And the R values increase, right, as you go this side.
Yeah.
So the identity that comes is NCR minus 1 plus NCR, right,
Yeah.
is
Is
equal
equal
to
to
N plus
n
1
plus
CR,
1 CR.
right? Now,
Yeah.
obviously, there is a, by definition, if you do algebra, you can solve it and prove it, but it's a visual identity, right?
Yeah.
If you are in the same row, your R values will go from R minus 1 to R, and NCR minus 1 plus NCR will be N plus 1 CR. This one will match, right?
Yeah.
That is the first identity. And the second identity is called the hockey stick identity. The hockey stick identity says this. So anytime you start from here, right, the end here, end row here, right? Correct. So you start from a point here. If you go like this, 1 plus 3 plus 6 will be equal to 10, right? 1 plus 4 is equal to 5, right?
Yeah.
You can extend it anywhere. Like 1 plus 3 plus 6 plus 10 will be equal to here, and here it will be 14. It will be 20, right?
Yeah.
Are you seeing some pattern here? Like this is like a stick, and this is the turning of the hockey stick.
Yeah.
So what is happening actually? You are saying that from this part of the Pascal's triangle where 2C2 or 3C3 or 4C4, if you go in this way so that you are keeping the two subscript same, right?
Yeah.
So if you are keeping the two subscript same, basically you have to go in a angular way. You cannot go straight down or this side, right? Because the number of terms are increasing, right?
Yeah.
Like 2C2, 3C2, 4C2, it's like this. And that will be equal to 5C3.
Yeah.
You understand? So the rule here is what is remaining constant, the subscript, right?
Yeah.
And the top parts are increasing, right, in a sequence. So you have
Yeah.
NCR plus N plus 1 CR plus N plus 2 CR is should be equal to N plus 3
CR.
CR plus 1. See,
Yeah.
right?
Yeah.
You have to start with the end of the row here, okay? Because if you start from somewhere here, it will not work. 4 plus 10 is not going to be 15, right?
Yeah.
You have to start from the end of the row here. Basically, technically, I should be writing not NCR, I should be writing RCR, right?
Yeah.
But you get the point.
Yeah.
From
Yeah.
here, we can easily say that this thing is 2C2, 3C2, 4C2, 5C2 till 11C2, right? So I'll go to the next row. It will be 12C3.
C3.
Okay,
Yeah.
that is your answer. So this Pascal's triangle, two things you need to know, this identity and the hockey stick identity. So hockey stick identity you have understood, right?
Yeah.
And you can prove this easily. Like if you just simplify, right? If you say NC, let's say RCR plus r plus 1 CR plus r plus 2 CR plus r plus 3 CR. You'll for sure be able to prove that it is r plus 4 CR plus 1.
Yeah.
You can verify it by putting any numbers. Okay.
Yeah.
So the question was about the stars and bars method, but the stars and bars method, when you apply, you will actually have to solve many equations, right?
Yeah.
The solutions of the equations are not hard. You have to apply the condition that its solutions have to be 111 or more. So you will have to do 11C2, 10C2 and so on, right? And you will go down to 2C2 and then you need to be able to sum this. Correct?
Yeah.
Okay. Uh, keep doing the Allen book and all. If you have any doubts there, you can ask me. Just make sure that you go through the sections there, beginner boxes, everything.
Yeah, I'm almost done with the beginner boxes, so I was thinking I would start the exercise as well.
So do that. After this, like maybe one more class we can do for PNC. After that, we'll do probability.
Okay.
Okay. I'll see you next time.
Yeah.